Good evening, folks. Hope we're all doing good. Yeah, I don't think we're refactoring tonight. We're sort of catching up on what's next, and yeah, I I guess I hope you're doing well. This evening, I think what's on the brain is kind of last time we were trying to write a loop for our entire prototyping process, and tonight I think we're going to see if we destroyed our city. But also we're going to see if we can figure out what all we need to do to get everything running again. And our hope, I guess, is that by the end of this process, we'll have a big enough loop that we can run prototypes end to end and start doing some new game designs. So let's see if we can get there tonight. All right. Um, so it's been a day or two. I don't know if we've got a mayor session to attach to. Um, yeah, it sure looks like it. It looks like we've got some other sessions going as well. Um, all right, and it looks like we left the mayor here. Um, okay, so yeah, great. So here we are, sort of picking up where that last session left off. You can see we're on Friday the 5th. Yeah, so I wasn't feeling well yesterday. Um, it was nothing special, I don't think. But, all right, so here's the mayor waking up, uh, knowing what it's doing, which is great. That's sort of expected behavior for our Gas City mayor session. We've still got some things going. What you are not. All right, it's trying to figure out how to get the analyst to work. Um, yeah, I'm not sure of the timing of this. I think it would help if I had timestamps right here. But it is sort of saying this is tailing a log, right? So between when this was running and when it was not running. So if this is like, if it was working, so I leave it running when I'm not here, so that we can see kind of what it got up to while I was gone. And this 20 minutes ago might have been like midnight at the end of June the 5th, Pacific time. Did EK. I'm not sure if the sitting for many hours was a system issue or just that the VM was not running. Um, I wouldn't over-index on that. Um, let's um, let's see if our work loop is progressing, and then maybe it's a good time for a hand. Now, I don't know um, my information about how long it takes a session to start getting deranged due to context usage is kind of out of date, right? Because um, we have million token context in Opus right now, and I don't think that that's like the last time I read the statistics, it was about, oh, well, once you get up to 50%, you're going to start seeing weird stuff, and it will start to forget things. And it said VM uptime is a more parsimonious explanation. All right, let's see how we're doing progress wise. VM uptime is an interesting one because it's not really probing. I was listening to Chris Hayes' podcast on AI again, and it was a very interesting episode. I think third in their series. This one was about whether AI is more creative than a 2-year-old, and totally fascinating stuff. Um, let's see here. So it found some loopback. Um, uh, Asking for a revise, and this did happen the first time that we tried to run this puzzle. I think down the pipeline, um, which is interesting. Uh, is it more creative? But it's also sort of about what is a 2-year-old doing that these machines aren't doing? And one of the conclusions that they drew, this cognitive scientist who was on the Chris Hayes podcast, was um, the 2-year-old is experimenting a lot, and they are grounding all of their experiments in their reality. They try things and they see what happens, and they have ground truth from their senses that allows them to sort of sense and act in a big loop. And the amount of stuff that you learn as a child is kind of gross. It's immense. You hear all the languages around you, and you can learn to speak all of them at once. You intuit theories of mind. You intuit theories of physics. You intuit theories of kinesthetics, how you move your body, you know, all of this stuff. And, you intuit reasoning. People talk to you in a reasonable way. They ask you to figure things out. You figure things out. And so they were saying that, you know, LLMs have this huge disadvantage, which is that all of their experience is mediated through language. And not only mediated through language, but none of their experience is mediated through direct experimentation and sensation. And so they don't have those, um, you could say, foundations of knowledge. That's how they put it on the podcast. And they put that syntax and language is sort of the icing on top of a huge mountain of knowledge. This is why people are so interested, or Jan LeCun, one of our big AI theorists, scientists, experimenters, is very interested in thinking about this problem of the world model and grounding the AI in the world model. Um, and, very in harmony with what was happening on this podcast, I would say. Um, I don't know, there's some interesting things about that. Um, if you think of the orchestration loop here as a sort of control system, right? Um, and a lot of the things that we've been trying to do is to set the orchestrator loose so that it is, in a sense, act loop, right? Um, and when I say sense act, it senses the world, and it receives all of this sense data, or you could say like state information if you want. And then based on its programming or its purpose or something like that, it reasons at some level about that data, and then it chooses some way to act further, to further its purpose, or to follow its programming or what have you. When it acts, it goes and it changes the state that it's about to read, right? It affects the world somehow, and then it reads what happened, right? And so control systems are in a sort of sense act loop. And when you have a robot that's intended to do a really specific task, and you put it in a sense act loop, um, you're asking it, please drive safely, or please change the temperature so that the house stays at about 70 degrees, or something like that. And you're not giving it a whole lot of latitude about how you want it to change over time. Oh, this kind of was happening last time too. Let's see, are we getting, yeah. Well, we were getting kind of crazy writes on the VM. It seems to be calming down now. I don't know how to stop that from happening yet, and we might get to the point eventually where I need to stop letting it like go wild inside of the VM. uh, but yeah, you can see, yeah, it's still kind of you can't see this, but it's definitely still writing quite a bit. Um, a child isn't a robot. It's not. It doesn't have a mission in life like to drive or to raise the temperature or keep the temperature within certain limits or that kind of thing. Um, and so instead, the yeah, I can see the screen looks kind of frozen, but it's because of this heavy write thing. And we've been running into this from time to time on the stream. It might be that our city is just a little out of date, and our adults a little out of date. Everything's a little out of date, and there are fixes for these in the main branch and that kind of thing. Um, but yeah, if we get a chance, I mean, yeah, it's still not letting us back in. It's still like writing a gigabyte per second, and I don't think that means that it's actually using up all that space. I do think that it means that it's like, misbehaving or swapping or something like that. So um, let's shut it down again. Shut. I see. We just need to do a hard power off. Yeah, shut down is trying to do orderly shutdown, but power off, it's, the power is just off. And before we start running our city again, we'll just work on this infrastructure stuff once more. Um, the most annoying sort of issue, in my opinion, right? Like, um, I didn't join this profession in order to, tinker with the insides of the car. I wanted to drive the car. Yeah. Um, and I've always kind of felt that way. Like some people are mechanics and they love to drive, tinker with the car all night. And um, but I'm always trying to use it as a means to an end. And if it's not serving that end, then that's annoying. Yeah, I'm just checking the Discord as well. Um, Hopefully, all of that, disk traffic wasn't going to Claude or, using up our limits or something like that. Let's begin with resuming our branch. We're gonna sync our branch here. Well, I guess here, step very one. Is anybody looking at our issue? I don't think so. All right. Um, this is kind of a message of its own, right? If you leave an issue out for 4 days and you're like, the concept of this repo is kind of fundamentally breaking, right? I want to depend on stuff in here as if it were kind of an artifact repository with canonical versions of things, and it's certainly not. you know, um, then you're not going to get this pat composability stuff off the ground. So we're just going to keep that in our pipe and kind of smoke it. I don't know the right way to react to that. Here we go. All right, let's get our tags back from the mothership. All right, we're gonna get our local branch going again. Okay. Cool. And we might ask it to rebuild. Another one that we're gonna do. We'd have to be very brave to update beads without seeing that they finally fixed that issue that we were dealing with. Yeah, you can see that there's no updated brew version, meaning I think that they haven't made a release yet that we could depend on. Spell beads. It's funny that that was a Firefox suggest instead of remembering that it was in my history. All right. Yeah, last month we had a release for 1.0.4. Let's see what this is saying right now. Yeah, they don't have a 1.0.6 release yet, I don't think. Um, all right. So, don't run BD dolt push pull until 1.0.6. That's fair. I don't think that we're going to do that. Let's see what the 2.1.1. Haven't looked at this at all. I don't think that dolt is in Gastown Hall. Dolt hub / dolt. Where are we at here? There's a new release 2 days ago. Let's check the release notes. Not a big one. Two point 1.3. Erase condition in acquiring auto increment locks, which it's hard to know if we were involved with all of these, like which ones might be affecting our gas city and causing huge amounts of writes. And we can have our mayor kind of investigate that as well. It doesn't seem like we're getting anything super earth shaking from going up a version from 2.1.1. See, we're right here. At the same time, it doesn't seem like this is super risky. It's hard to tell. I think I'm inclined to try it. We can always painfully revert if we need to. Okay. Interesting. No, we don't. We're not causing any big right storm here. I don't know what would be taking so long for this to respond. It's not like we're running a bunch of stuff here. Maybe GitHub is expensive? Yeah. I mean, it seems kind of expensive. Hard to say. All right. We don't need to be there. We're already sort of we're rolling the dice on the new dolt version. Cool. All right. Um I guess this is this. 2.1.153. Yeah. Okay. Um, what else do we have going here? Go, curls, which is a beads viewer. R clone. I don't really need a new version of this. The existing stuff seems to be working just fine for me. Warning, the following tabs are not trusted. It's interesting. I mean, I've installed stuff from them, and certainly this tool is from this tab. All right. Well, let's talk to the mayor and see if maybe it can diagnose like heavy writes that we've been having. It keeps reusing this session, and to me that sort of implies we had to hard shut off the VM due to heavy disk usage. Feel free to root cause. Please root cause that. We had such issues before, so perhaps memorializing what we find would be helpful in the future. We might have memories about this also. Okie doke. There's no huge reason to change directories to start the Emacs daemon, but I think it will, like, yeah, it started our shell in the right directory. All right. Dolt health advisories? Could be. Mm-hmm. Okay. Yeah. All right. While we're being specific about that, I guess we can, yeah, we tried this one. This one was almost like if you follow the rules, then you would just solve the problem. I hope that there's more complicated versions of it. King Kong Khan. Place a diagonal mirror in each region. At the positions indicated, a laser beam enters the grid. 3 is it's reflected by as many mirrors as the number indicates, so it takes 2 mirrors, and then it leaves over here. Every mirror must reflect at least 1 laser beam. I don't have a lot of fun with lasers, but maybe this will be a little bit more fun. They've shown all the clues. I think that's a little different. There's a version in Simon Tatham where you're supposed to optimize the number of observations that you make before you can place all of the balls to reflect all of the lasers. And I just I'm not super into the optimization ones that don't depend on reasoning. They sort of depend more on luck, you could say. 3 dolt remote V processes were consuming lots of RAM. Yeah, so I guess we're hoping that the dolt that we upgraded wouldn't have this issue, but it's hard, you know. It's kind of a black box to me right now. I know that it's a get back data store, and that's pretty much it. Here we go again. We're at 1300 megabytes per second in this virtual machine while we're, you know, hopefully it will recover for long enough for the mayor to figure something out. I don't think this has anything to do with Krita, probably. Ah, we're back down to 150. And it's going back up again. Uh, yeah, we're just riding this wave of disk performance on the SSD up and down. I mean, to be fair, it's not using all of its disk transfer headroom. It does, it will go to like, it will go faster. But yeah, this kind of thing's not very encouraging. How am I finding Claude with issues with environment or self-diagnoses? Oh, yeah, yeah, no, it's a good question. Hey, and nice to see you. Um, I think it's a weird thing. I was talking about this a little bit earlier, right? Like how Claude is not receiving ground truth. And I think that it's not in that loop, right, where um, it's constantly receiving sense data and then it's constantly acting on that data. And it seems like that's the kind of thing that you would want to do because that's very expensive, right? It's like data is flooding in continuously. I'm looking at the process monitor in Windows, which is hosting my VM. And, every tick, every second or so, it's giving me more and more data. And I could get really fulsome data, right? Like I could have it looking at top like all the time, and it would generate these massive logs, and that's sort of like what it's like to be a human, right? Uh, we've got all of this sense data coming in from our eyes and our skin cells and our hearing, and it's very rich, right? It's like it's 4K all the time, right? And from that, we're picking out slices that are important. And we're dropping a lot of stuff on the floor based on like our focus, right? Our attention. And so this is a big problem. It's been a problem for a really long time. When I was going to school, 20 years ago, you could talk to a security researcher about this problem, and they would tell you, oh, yeah, I mean, there's lots and lots of logs, but there's way too much network traffic to try and read everything in every log, to try and get patterns out of everything. It's just happening too fast, and there's so much coming at you all the time. And so you have to pick and choose which things are important in order to find patterns, right? And so his particular idea when I was going to school was let's do some visualization on top of this data. And we're going to see things with our visual system that a computer wouldn't notice with a bunch of pattern matching or etc. And the state of the art in the mid 2000s, that was basically the problem, right? Um, I guess the issue that you would have now is like, you know, it's sort of like there's a funny story by Borges about a guy who remembers everything, and in like a lot of detail. Hey, are we back? Can we actually do stuff? Um, Curious. It seems to have figured something out in between the time when it could think and couldn't think, right? Um, and so did Claude notice right here that its brain kind of cut out for like a minute or several minutes while I was talking, right? And no, I don't think so. I think like this counter started going up again when it started, you know, when time started rolling again inside of our VM, right? Um, and that's a weird thing, right? Like, if it would notice these little blips in its memory, then it could get concerned, right? Even at the top of the stream, I was like, it got really concerned because it was like, wow, this took forever to start. And I was like, well, I haven't been here for 2 days, so maybe you're just noticing that the VM went down and now it's back. It doesn't have a theory of its execution environment, and so I think that's exactly what you're getting at. um, and what would it take to get a theory of its execution environment? Um, what would you want it to be paying attention to? Um, yeah. Same pattern now. Okay. Lots of BD activity. So we did that. Um, yeah. So we were trying to reap a bunch of operations. I think that makes sense. Um, and then lots of stuff was happening to close all of these convoys and workflows and things. And then um, they're going really fast. And when they're all writing the same thing, they're all potentially like trying to get locks on the same tables in Dolt. Um, yeah. And then, yeah, it's trying to. Why adding swap didn't save us, which we did. Um, right. When the Dolt sub process fleet spikes, and we have dirty bites to flush. Yeah. Delete the recovery snapshot. Um, we need to do some dolt garbage collection. Yeah, great. I think these are all like appropriate things for us to do. Um, oh, we didn't read far enough. It was still writing. Um, rotate events JSON-L. Yeah, yeah. I think yeah, throttling future bulk BD operations. I think that's a good one too. That's sort of like a good intentions one. We have to tell the mayor, uh, you know, don't do 50 at a time. Um, yeah, just go through and delete things on your own time. Yeah, let's definitely. If the supervisor's offline, then I need to run the Dolt GC, right? Um, it can't happen in the mayor because the mayor is kind of depending on that supervisor. As far as I understand it, we haven't totally gotten into that those level of the internals, but okay. It's here. Let's oops. Let's do that scroll back one more time. It's still not. We can't quite read this. It got a little cut off. Yeah. Yeah. Let's do your first suggestions. I'm not sure about throttling ED ops, although that does seem to be the proximate cause. I hope I answered the question. And thanks for watching again, Airbnb Bacon. Um, although that does seem to be the proximate cause, um, we would rather automate away this problem than put it in a prompt or memory or something. Hmm. And I'm sorry if I'm not getting to your chats right away. It's kind of off in a corner. I need to figure out how to get it in front of me uh, so that I'm seeing it right when it happens. But yeah, happy to see you again. Let's see. This might work. Uh, I guess while we're pondering this, let's ponder this question of Claude's environment or self-diagnosis, right? Oh yeah, great. Here, I'd love to read what you're saying. Yeah, yeah. Now, what's really interesting about what you're saying, that Claude gives up and it starts to hallucinate when it's having issues with self-diagnosis, is look how its knowledge is not grounded, right? It's not grounded in all the stuff it learned on the internet. It doesn't have an example of what's happening, and it's not really looking at itself, right? It's not generating text out of stuff that it knows. It's trying to reason from what it knows to what it doesn't know, or what it's not looking at to what it's thinking, something like that. And I definitely found that I'll give a slightly different example. We'll kind of work our way around to this one about hardware. Um, so I was running Claude in operations one time, and I was asking it to help me root cause a problem. And I was like, well, I can't just give you a shell into, yeah, not knowing what it doesn't know. That's right. Well, now I think that it could know. That's what's kind of funny about it, right? And some of the like self-improving stuff we're starting to hear out of Anthropic. That's like, hey, it's starting to design itself, and wouldn't it have to know like what's wrong with it to design itself so that it gets those things right again? And so it would have to, like, maybe they're working on stuff like this. And certainly like what we can do from our point of view, vantage point, is right, like we can point it at certain things to notice it. And I can keep I can have it sort of root causing things until it's blue to the face, and it's like, you're absolutely right, I totally am causing these write storms that are taking out the VM and ruining your evening. you know Absolutely true. uh I think it's like, can we solve this problem from where we sit, right? Can we put the agent kind of into the loop of itself? So I think that there's a way to do it, kind of, which is like, yeah. So I was working on this problem in operations. I was like, you can't have read and write access to my database, but you can, and I have no way to pipe you into, a certain production system, but I could run read-only Rails commands for you. And so it started sending me commands, and it was very funny. Like at that time, like MCP was the new hotness, and it was like, I became the MCP server. I was a Rails MCP server for this thing, and the interface was, it would type commands into its prompt, and I would transfer them over to the Rails prompt, And then I would, marshal the output of that back into my prompt. And after a while, it would go, okay, I get what's going on, and it could lead me right to the root cause. It could run a script to fix all the things we needed to fix. Um, yeah, the team reviewed it, I ran it, and it fixed it. Um, I think that's really interesting, and it's sort of like what people are trying to do. I think when they are sort of pointing their gas cities at gas city as a project, right, and saying, "Make yourself better." you know, it's slightly better situation than like make me money. I think a lot of people are trying to use their gas cities and just say, make me money, and they want to see what happens. But a much more complicated problem, I think, than make yourself faster or more reliable or something. All right, let's see what you gave for me. All right, we don't need the whole recovery snapshot. That's fine. Um, we do have a lot of headroom on the disk, so I wasn't totally worried about that. Yep. There is perhaps a framework concern. When we call beads too much, then we're, shooting ourselves in the foot. And specifically, like the hypothesis is something like, yeah, go ahead. Yeah, yeah, you're right. So talking about this, like, whether or not um, it reasons the way that you do, right? And so certainly, like, when I think of the way that I make decisions or I make designs or something like that, I'm listening to the whole conversation. I'm trying to take into account all the points of view that are being raised. I'm trying to reason, say, from a certain, safe starting point to like the new revelation that will kind of untie the knot that we're trying to deal with. And sometimes that's a creative process, but sometimes it's just about keeping everything in your head at once. Richard Feynman would sometimes talk about that this way too, right? Like, I think I remember reading one of his stories. He would like challenge his students, describe a particle for me, and he would sort of they'd keep adding detail and detail and detail until they'd finally come to some place where some detail that they said contradicted something they said earlier, and so he'd go, "Nope, that's not that. This is where you could kind of fall off the wagon." He could do that because every one of those details could matter, and he could keep them all. And obviously, like as a physicist, he was skilled at math, but he was skilled at kind of plucking out the key features of what he was being told, and then just keeping them in his head that way. And so I think this is another thing that you're talking about, that like even though there are concise instructions, right? It's biased towards what you're talking about lately. It doesn't remember super important instruction. Base all of your life and your epistemology and your theory of knowledge on this fact right here, and then it will kind of like forget that with equal ease to like just some random detail that you were talking about in the conversation that's not supposed to be hooked to everything. And for some reason, us people, we understand when ideas are supposed to be hooked to everything, or what seems fundamental, or, if you sort of take out this block, how the whole tower is going to collapse. So it's a very important block, and you can't forget that one. Uh, and how it's all related. Yeah, yeah. So I think that's right. It's like if it had all of this detail at once, right? And we were talking about sense data, right? But you could talk as well about machine data or whatever. Um, it needs to kind of remember everything and how it all relates, and it needs to read another paper about like forgetting, right? It needs to forget things that aren't important and remember what is really important. Uh, so yeah, I think there was a Microsoft research paper about that fairly recently. All right, let's see. Uh, okay, so we're believing that like all the rights are fighting with each other, kind of, and that as it's trying to, yeah. Oh yeah, yeah. Well, I mean, I think that this is yeah, fascinating time, a totally fascinating time for neurology, right? Because and I would say like a lot of things like philosophy, We're getting executable philosophers. How cool, how interesting. We're getting executable knowledge models, how interesting. And they provide these really interesting contrasts, right? Um, or if you want to talk about art or consciousness or a lot of different things, right? um, how special is a mathematician? And as they've gotten more interesting, they provide more interesting contrasts, and I think that this is another interesting thing about that podcast I was mentioning before. Like, yeah, this third episode of Chris Hayes' series where he's talking to the cognitive scientist about the contrast between the model thinking or learning and the like 2-year old learning and thinking. And they're not doing the same thing, is the thesis of that episode, I would say. But I think that there's a certain interesting evasion that you can do in this sort of argument. And it's an evasion that, AI people would have said even back when I was going to school 20 years ago, which is that the you don't care if it thinks like a person, right? You care if it can do the job, in a sense, right? So this is how Russell and Norvig, Stuart Russell and Peter Norvig put it in their textbook that I read. It's that we don't want to know if it can think rationally. We want to know if the system can act rationally. And acting rationally is interesting because you might be able to act rationally without thinking rationally or thinking like a human, right? Yeah, exactly. And so it's like, and that means that they can do certain jobs for us. And you can ask, like, well, is consciousness a job? Is language a job? Is thinking a job? Can it just do that as a job? And um, this is why I find the question of like AI art so interesting too. It's not about just is it harvesting. You can ask, and I think that the podcast episode brings this up as well. It's like, is it cheating because in a sense, it's starting from this point of all human knowledge, and it's already been bootstrapped so far up that, like, being proud of it climbing to the top of a certain mountain, it's like you're not acknowledging all of the Sherpas and camps and foundation and structure that got us all the way up to that point, right? It is standing on the shoulder of giants, but at the same time, right now that we're here, is it able to do sort of mountaintop work? Yeah. Yeah. Can it do interesting software engineering? Obviously, I think it can. I've been playing around with that, enjoying that. Yeah. Can it do politics? uh, Maybe it needs to know more about the world first. Let's see. What else have we got in our. Yeah. The underlying. Okay. So this is still happening, it says. Yeah. There's no heat on our disk right now. That's good. Um, let's see what we can do. So it says it needs a maintenance window. Yeah, I can ask it to do this. Let's see. It might like be like taking itself down for a minute. And it might be that, I mean, it is weird for me to be going like, do I need to run this manually? Like, why? Don't think we've really read this before. It didn't tell us too much. Interesting. Are we back? Was that it? Okay, cool. I don't think this changed much since we deleted like 9 GB. Hmm. This seems a little squirrely. Again, it's sort of like internals that I don't want to mess with that much. Like if I want to treat my agents like little coworkers and just talk to them, then all of this stuff is like me having to go around and like oil my coworkers so that they'll start talking to me again. I did have a friend who entered neurology approximately 25 years ago. I think she was interested in issues sort of like this, but she ended up working as a doctor for the VA, which, respect, absolutely. Okay. Yeah, if it is trying to get a lock on 10 gigabytes worth of data and we don't need so much of it, I think that's good to know. Well, this might be a good time for us to learn about dolt a little bit, honestly. I know that it's so what do we understand about dolt so far? It's a get back database. Just like any MySQL. Um, and there is dolt hub. We can sort of back up um, our dolt if you want to host your own. I don't particularly need Postgres instead of MySQL. I'm not sure exactly what that's implying. Um, I think in the past it would imply things about maybe the amount of ACID that was available, the difference between MySQL and Postgres. Uh, Differences from dolt. Okay. Ah, interesting. Can't push to their remotes. This frightens me, I think, as a database feature. Not that I've been backing up my, you know, dolt like I should. It's only 1.1 times slower than MySQL. To me, that's pretty fast. 100% compatible. Super cool. Um, yeah. So why would we be getting huge performance issues? Like, it's like it said, we don't even have, a couple hundred rows in this, especially for our rig level stuff. Okay. It's quarantined maybe because we've had these problems with like different versions of dolt having to be used. Uh, why would this? Yeah. Hmm. Again, this is not super interesting. Sure, if it wants to investigate, be my guest. Yeah. Mm. Let's do the investigation and take it from there. It's possible that we're getting row count drops for a real reason, right? Like, for instance, flattening the database is removing a bunch of spurious duplicates or something like that. But then it's triggering this alarm that, like, hey, you're totally getting rid of all this stuff in your database. Um, and again, it's sort of requiring us to dive kind of deep. I'm more interested in getting back to puzzle games. Hmm. I guess this is getting into whether you have to interact with dolt as an interactive thing. Let's return here a little bit. Use get like CLIs to, well, this is for actually like altering the data, right? Dolt CLI. The same commands as get with some extras. Okay, we could dolt SQL. Maybe this is like a good exploration. Yeah, strong evidence of a false alarm. And these are, so orders are scheduled workflows that happen in the city on a regular basis. Hmm. Order tracking beads are being created and closed. I see. It was deleting expired entries. All right. Sure, let's try it again. Maybe doing it at a period of low activity will avoid this issue. Okay. So the problem wasn't that we were compacting our database. The problem was that we were in the middle of writing a bunch of stuff while we were doing it, and it was starting to get confused. Let's see. Dolt SQL. Okay, I see. Well, let's try the simplest thing we can do. Q. Okay. Let's do. Oh, okay. All right, fair. You got me. We're trying to remember some MySQL now too. Okay, great. No, these are the... that's funny. How are we going to get to our... Yeah, right. These are, you know, these are my SQL tables. We're not seeing our, like, our rigs or our city. Hmm. List tables in the working set. Let's try that. Oh, I see. Now, okay, this is starting to make sense. Um, I'm trying to remember exactly where it is. Um, but we do have like I think we're here. Yeah. So here we are. No, maybe not. Not a valid adult repository. These are the names of our different we have HQ, which is for the city level, Book Show, which is one of our rigs, and Incremental, the puzzle rig. Aha. Okay. Now we're getting somewhere. We've got all of these tables that we could be looking at stuff. Some of these are probably views, right? We've got issues. What other interesting stuff have we got here? Diff a table. We don't need to. We're really more interested in like, okay, this is point in time reading. I think that we are now ready to run a SQL query. So my favorite way to discover the schema of a certain table. Oh, right. This is a query. There we go. Yeah, as you can imagine, it trying to render all of this text is it's a challenge. Let's write a file. All the same, but we're not going to be in much better position reading this in Emacs, but you never know. Oop, temp dolt example. Okay, here we go. So this is all the stuff that's in an issue. And you can see that like we've got how many characters in the header? 1,000. How many columns do we have here? Like dozens, I suppose. And here's our first issue. we've got a crap load of text apparently. Um, so this is yeah. Universal accept work formula, the intake wisp that Sling attaches to every department's workbeat by default. It performs 3 gates: conformance check, cache lookup, and classify resolution. Yeah, we'd love to just get this. And this is the description title: molecule accept work. So this bead isn't just like a task bead. Um, Lots of the stuff in our city is stored as a bead, including this molecule, this formula. Let's see, what could we do? select description where ID equals in 00H. I guess I gotta do backslashes here. Double backslashes? Maybe I gotta do this with like some double quotes here. All right. We overrode our dolt example. So here we go. All right. So this is the description that is in dolt. Which as you can see, not sure why it decided to go a little longer right here. It's amusing, I'd say, that it definitely seems to be conformed to 72 characters, except for this one line. And then this one is a little bit longer too. Um, nice, yeah. All right, so here we go. Massive, super cool. But yeah, no, hopefully if they're not all trying to lock 10 gigabytes at once and read and write that and stuff. All right, good. What's left? Um, Before we file the bead, let's look for related issues in Gas City. Yeah, I keep saying that someday we're going to actually return all of this work upstream, but I think we're still trying to wrap our arms around it. I don't think that we know enough to go. Our expertise is good enough to affect that project yet. But I think that we're earning a lot of battle scars. That's cool. Yeah. I do wish that okay. Hmm. Well, and this is interesting, yeah. Um 2348. Let's go look at it. It really feels like we have a contribution to make here. And it's hard to tell sometimes. I guess it depends on how old the issue is, whether it is still relevant. Oop. 3 weeks ago. I mean, that's pretty. Yeah, yeah. Hey, Wow. Well, that's cool. So I imagine if you're starting with work, this is the end of my day. At the start of your day, that would be like in Europe, maybe. That's cool. Happy to have you here. Thanks for lurking. Hey, yeah, right on, right on. Yeah, I have some friends that work in Europe as well. In my last company, there were offices kind of around the world, but the farthest east my team got was Ireland. Yeah, but yeah, yeah, be welcome, of course. All right. Just have a city that's working, and then at some point, then it will cause this race. Yeah. Did anybody else? Okay. Yeah. I think this is fine. Okay. There we go. It can get excited and just run the GHCLI and be me. So okay. When we finally tracked it back, it sat for 15 days. Yeah, no, that seems good. All right, cool. Well then, I guess I guess we did it. We might have figured out this infrastructure problem for ourselves, and hopefully we won't run into it again for a bit. Maybe it's a little silly. Maybe we just should have noticed faster and tried to a little harder to fix it the first time. But hey, every little bit helps probably. Cool. Thanks for that. Um, Before we resume the game, let's before we resume, let's do a GC. Let's do a GC handoff and start a new session. All right. So I believe what'll happen, hands off to me, is that it will write its hand off and then the session will die. So we might as well do a little bit of this. Okay. Um, we've got mirrors. Um, we only get one mirror for D1. So, and then it exits over here. I think it's just got to go this way, right? And I didn't really look to see if you're allowed to draw lasers across each other. I think you are, though. Ah, every mirror must reflect at least one laser beam. Okay. I don't, yeah. Yeah, we are seeing some crisscrosses. So. All right. Without looking at it too hard. I suppose we could color all these lasers differently, and that would look super sweet. What's the regions thing about? Does that mean there's at least one mirror in each region? Or at most one mirror in each region? Ah, yep, one in each region. Yep, sure enough. So this one doesn't have a mirror. So anything that goes through there is just going to go straight through. Although I don't see any. Maybe there's a way with a couple of mirrors that it could bounce around. Something like that. All right. B has to get to 3. Well, I guess the other weird thing about this is that we also know there's no mirror here. Wherever the laser travels, right? Maybe that's an even more interesting fact. So we're going to have a mirror here or here, and something's going to bounce off of it. I think that's the other. Yeah. So yeah, this is a definitely interesting one. How do you make sure something bounces off? I think there's also a sense where like say that we start shooting at the B3 laser this way. We can't just direct it off the board. It has to go toward the center somehow. Maybe it would go like this, for instance. Hmm. We know that A's got to go a couple of times. It could bounce down and then over and then down. That's a way to do it. Can you bounce it up, up, over, and then down? Yeah, that works too. Are we stuck doing like hypotheses? Like, there's no way that you can get a mirror like this coming out of the corner because it'll anything that bounces into it is going to get directed off the board. So if it is in the corner, it's got to direct things along the side. And the same would be true up here too. But then where's it going to go? You know, the amount of bouncing that you have to do to use this mirror to get you anywhere. Oh, that might work. 1, 2, 3. That's a way to get to B. This kind of reminds me of fun board game Ricochet Robots, where you can make turns, the object is to like get the robot to the goal state in as few turns as possible, and the robots go forward until they hit an obstacle, and then they're allowed to turn. In this case, you really force the robots to like turn a certain corner. Hmm. I guess another interesting thing that's happening in this one is that we've got two lasers shooting out from E and B. And one of them is going to have to go free all the way through. Uh, unless we put the mirror right here, then one of them would just have to go straight all the way out to here, or in the E case, all the way out to here. In the E case, it's only two mirrors, so it's got to go bounce, bounce. And we're going to have two mirrors on the same row that do that operation. If we put one down here for A3, again, you kind of can't make the single mirror for E go off the board. If it was down here, then A3 would have to travel all the way out to here. Uh, it's not all obvious how it could bounce around 3 times to get to here, but maybe here. Well, you can't put a mirror here and then a mirror here because you'd only get one per region. Hmm. Say we had a mirror here or here. I don't see any way to shoot it right now. Maybe there's like a really complicated way, but I don't think that any of these lasers emit of that much bouncing. All right. Okay, cool. So as suspected, the mayor handed off and it's re-bouncing itself. All right. Cool. Yeah, it is kind of remembering, I think, where we started from last time. It seems like it would be reasonable to um okay. There's a bunch of molecules going for this prototype that's in flight, which is great, but I think that's getting answered by other agents in the session list. Let's just double check. I wish I could write a little memory for myself that says, go to here and do this. Maybe I can just do that. Useful snippets. I might already have some like yeah. Start a new file. There we go. Okay. I think that's probably enough to remind me of what we did. I'm not sure what the antiquarian is doing right now. Um, this is for the refactor, I think. I sort of wish it was using the um, instead of this ID. Yeah, this is our refactor tutors content for rig as pack source, and then adopt some packs. Although we did run into that problem, right? That they got rid of our packs out from under us in the Gas City packs repository. Okay. Let's read the Oracle answers first, I think. If it's going to alter that bead at all. It's a big project plan, and it would be nice to keep that working. We're sort of in the phase 2. We might want to just pull in that old commit, um, copy it, and then move on. This is helpful too. This is not necessary to do our puzzle work, right? But it's like helpful to create lines of force around concierge stuff. But like it says, we don't have evidence that it's working great or not working great. But all right. Synthesis. Yes. I think that we did that already. Um, I can explain that. Right. I think we rebuilt GC. You can confirm with a GC agent list and a GC version. Uh, um, feel free to do the config explain. Let's hold off on the upstream change. Yeah. So hopefully now that it's, yeah, the version string wasn't bumped. Probably I'm missing some tag or something like that. Or I was missing it at the time that we built. Okay. I think one thing that's weird about this is it seems like there are so many possibilities. I guess one thing that we can clarify here is that, these bounce off one mirror ones were really easy. We've got to stick a mirror somewhere on this row. And, by the same token, somewhere on this row. Because we've got to divert the laser at least one time along here. We can say that about all of our rows and columns. I guess the whole puzzle is in three states: empty, forward slash, or backslash. And so I don't know if it helps that much to eliminate, but we could definitely have empty or forward slash in this one. If we did have a forward slash in this one, then this one would be empty, and so would all of these. Hmm. Like if we tried to put our mirror here, what can hit it? And it's sort of what can hit it in a productive way, right? Like I was trying to explain about ricochet robots, like if the path is too long, it's not even worth following, really, right? And so I can definitely construct really long paths of mirrors, but there's nothing over 3 in this puzzle. Interesting. So I guess that's another way to think about this issue. If I have to stick a mirror in here and a laser has to go through it. If I stick it over here, then the laser's got to go all the way through to here at least. And there's got to be a mirror here or here. I definitely can't place a mirror right here. The reason I say that there has to be a mirror here or here is that this mirror has to be productive, right? Like it would bounce here and then it's got to hit one of these squares. It can't just travel off of the edge. Like all of these laser lines terminate. They all have two ends. So we could go like this and this. And then and we can't put a slash, a forward slash here or here, because that'll just take it off of the board. Because if we put a slash here, then this region has to be empty and the laser will go off. And if we put a slash here, then this will be empty. So it seems like there has got to be a backslash here or here. And then we can infer that all of these are empty. That seems helpful to me. Well, I should rephrase my remarks a little bit. If this is this way, yeah. So we should mark this a little differently, like so. Let's try the case where the productive mirror is over here. If we put it this way and a laser comes through it, we can't get the laser that falls off the board. We'd have to come this way, and then it would also fall off the board. So the only other real option is going like so. There is really no way to come from this side then. It has to come this way, fire in this way, and it's in the kind of the same position. So yeah, actually I think that we are kind of convincing ourselves that these have to be empty no matter what, because they're empty in the only two cases we can think of where we put a mirror in this bottom left region. Okay. Great. Yeah. Great. Those would all be good to do. We can leave it open. We can leave one open as a tracker, as you suggested. Okay, cool. So yeah, I think it's good to clear the deck. So the next mayor isn't like redoing all of this paperwork. So we're going to bounce one of these. And then we're going to bounce it again. And then we're either going to bounce our laser off of into A3. That would be one of these two. Or B3. That would be up here. Or this one. Yeah, right. This one. This one's intriguing because it would mean that we know how to bounce E2 there. We know that this one, it either has to be here. It certainly can't be like this. It's either this one, which it's sort of stuck, or it's going to be this one. And if it is this one, then it would definitely be this backslash mirror over here. And E would kind of go like this. Then B would start kind of bouncing down this way. A would be interesting. It would have to go up at least this far. And then it seems like it would have to bounce a lot to get to 1, 2, 3. Maybe that one. Well, that doesn't work because we know we have to go this way. 1, maybe this one, 2, 3. That seems like it kind of works. So far, it's the only one that's been able to figure out a way to use this right here. It seems pretty hard to bounce something into A without using one of these. I guess there's a path if we went like this, this, and then this. But then, how do you... Then there's actually no way to affect B. It will go in a straight line. So that one kind of doesn't work. This is a fascinating puzzle. There's lots of possibilities. I think we're looking for like the next obvious inference to try and accumulate something. Like I think creating all of these hypotheses is not quite it. It's not exactly what we're trying to do. Let's see if this is the same white. Okay, it's not erasing super well. It's a consequence of using pencil, I think, instead of like. Yeah, not quite what I'm going for here. That's okay, but it is kind of like swirling around there. How about a really solid, like, okay. All right, that's pretty nice. Maybe that's a little better than pencil. All right, but we did convince ourselves, I think, that none of these are going to be used. That's nice and bold. Maybe I should have been using this all along. All right. Promotion for vocab. Yeah. I think promoting vocab will be generally useful. Is a workflow needed? It keeps, or is it straightforward? Talked about this on a few streams, of course, but yeah, I really don't want vendor lock-in, and so any magical features inside of Claude that are specific to its session are not welcome. Not for me to use. Uh, Not trying to look at the solution. Mm. It's a little difficult to do like this kind of thing without undo, right? A3. Does the fact that there are 5 laser streams, it doesn't imply that there are 5 mirrors. The number of regions implies that there are 1, 2, 3, 4, 5, 7, 8, 9 mirrors. There are 9 mirrors, and there are one. Let's start from A. 3, 6, 7, 8, 10. There are 10 bounces and 9 mirrors. Does that mean only one mirror is used twice? All right. If we stuck a mirror here on B3, that we could get there in one bounce, but we don't. So we need to have a couple of mirrors along the way. It needs to bend a little earlier. It can't go this way. It has to go to the left. That means it needs to hit the back of a mirror like this, then hit it again. You could imagine a scenario where we would go like so, and then like so, and like so. That would force the E. Interesting. Well, if B did that, like went through this mirror, then we'd have to take A right to here, A like this. Then it has to, one of these has to be used. And what's interesting about this is that then there's no way to do E. We'll have covered all of the things that E can bounce off of here because we tried to get B home, A home, And A needed to bounce twice in these two regions here. If A didn't bounce here, it would have to bounce in one of these two. Because if it hits a mirror here, then it flies off the edge of the board. If A bounced here or here, if A bounced here, then it would definitely go here and bounce up this way. And then there's no way to get it there. A went here. It would have to bounce down this way. And then it would have to go across here. This is starting to look like there's enough scenarios here. So let's pretend that it looks like so. Or it can't do, that one doesn't work, right? This is the one that doesn't work. Gotta look like so. That means that these aren't used, right? This one is how B would have to go. There's something in this region. It would have to bounce down here. And finally, I have to bounce across like that. So this is sort of one world. And look at all the stuff that we've used up to do that. We would definitely be in this scenario of this mirror over here. Then we have to take this one. E would definitely be in this scenario. It would be in this one. I'll just draw them backwards. Does that check out? It looks like we've got a mirror in every one. B, E. This is the double used mirror right here. It does both B and E. And all of the other ones are only used once, just as we did our mirror counting and we did our bounce counting, and we have only one double count. So that one did work. We can try the other scenario, but I think we're forced to do something like this, this. We're going to take one of these up to A. So we haven't really covered, B has got to get reflected somewhere along this line, because there's really no way for it to sort of backtrack over to this eastern edge of this region. But it sort of raises a peculiar question, which is like, what is this region going to get used for? Yeah, so this one, so the A path would go through here. And then in the B path, you're really stuck with like needing to use this column like twice, but not being able to for any like good logistical purpose. And then in the E world, kind of trying to figure out how to make this area useful. Yeah, I think that they're kind of stomping on each other. Um, like you have to either, yeah, there's no way to sort of make this useful. All of the lines that look like they're getting used are kind of passing through it. Like even if you bounce something like 1, 2, 3 for E, and then you have to bounce something in here, 1, maybe here, 2. But this region isn't getting used. That's a weird thing. It's because there's like I don't think there are 2 double mirrors, but that scenario is getting kind of complicated. Um, oh, and now it's getting confused with orchestrating Claude subagents when I'm trying to say formula instead of workflow. Mm-hmm. I'm concerned we will cause a bunch of contentious beads activity if we do the bulk loop. I think we've had some other processes do this successfully, e.g. batches of 10 ingestions. Let's try number 1. Yeah, I mean, we made a hypothesis that would work, right? It's this left one. We could draw it for posterity. I mean, I think it is the correct solution. I'll just highlight it like so. We can see if it's the same. I guess we can draw them in. So it's like back, and then there's a back, forward, back, back, forward. Yeah. This is their solution as well. I don't think we did a super convincing job of saying like this is the only solution, which is always like nice to be able to do. It's like we're sort of testing our understanding of the puzzle. Coburine. Blacken some cells and draw a single closed loop in the grid. How many black cells are orthogonally adjacent to this cell? Numbered cells are not black. Two black cells must not be orthogonally adjacent. And all white cells must be visited. Okay, this is cool. Sort of, again, sort of like a reverse Slitherlink. The other big ingestion source that I want to kind of get to, I don't know if we're going to get there before we actually start prototyping. There's a puzzle designer called Naoki Inaba, I think. Yeah, a prolific designer's index of his types. Um, I think that would be good just to get a sort of different flavor of puzzle. We saw, I guess, did World Puzzle Foundation post? I should check. It doesn't look like they have posted round 5 yet. So I'll still hold off on sharing those puzzles. All right. So this is like, we know that it's here. And we know. I didn't check to see if it was the 8 neighborhood or not. Orthogonally adjacent. Okay, so we've got some erasing to do. The loop doesn't go through the numbers. Okay. So for instance, we know because this is in a corner and because this doesn't complete the loop. Loop doesn't go through the numbers. All right. Only one way through a couple of these cells. This is interesting. It's sort of like an unclued shaded cell. And now we've got to fill in at least one for this one here. Okay. Now it's got to go this way. We know that there can't be any adjacent to a black cell, so the loop's got to go through here. We know the loop can't go through this dead end, but it's got to go through here. Then we need 2 to do this cell. There we go. All these drawings that I'm doing are like forced moves. Okay. This is a dead end now. Which means these are not. Another dead end. This is legal because they're touching diagonally, not orthogonally. And this is a dead end because of the numbers in this in the loop here. So this is open and this is open. And we have to go through them. Only got one on this side. This is a dead end. So this has to be used. This can't loop. This is now a corner. This is a dead end. And there we go. Cool puzzle. Let's see, black squares on 3, 8, 5, blank, blank, 1, 3, 6, 8. 3, 8, 5, 1, 3, 6, 8, 4, 5. Oh, and there's one at the end, 8. Yep, we did it. I like this puzzle fun. Maybe I'm a sucker for Slitherlink. Is that it? This one, Kojun. It's sort of like the rippling, the earthquake one. Every region of size n contains the numbers 1 to n exactly once, just like rippling. Orthogonally adjacent cells must be different. If two cells are vertically adjacent, the higher number must be higher than the lower number. Okay, so there's sort of a temperature kind of thing going up here. Or you could say gravity too. It's sort of the opposite, like higher numbers are lighter or more dominant. Maybe it's more like hierarchy metaphor. I think it would work just as well if the numbers were reversed. Okay, so anything that has only one square in it, 1. We know we can't put the 1 on top of this 5, 4, 3, 2, 1. So this has got to be 2 or 4. This is sort of similar to there's another puzzle called Adjacency and Unequal in Simon Tatham, and they have to do with relationships like this. And this one has implied relationships of less than, and also of not having the same number adjacent. Yeah, in the adjacent one, there are markings in the grid, and you know that the nearby number is either next to this number numerically, 2 or 4, or it's not next to it, meaning it can't be 2, 3, or 4. And so that's similar to the no adjacency rule that we're going to follow right here. Can't put a 2 next to a 2. And it happens to follow the gravity rule. But we had no choice. We can't put this 2 next to this 2 either. And we got to put this 1 over here. Can't put this 2 next to this 2. And there we go. We can't put the 4 on the bottom. We could put a 3 here. And we can't put the 2 here. So it's got to be the 3. The only thing higher than the 3 is the 4. There's our 2. We can't put a 2 or a 3 here. So we were forced to put the 1. We're forced to put these in gravity order. And this one's very easy because it's all gravity. We can't put the 1 on top here or next to this one, so it's got to go here. We can't put a 1 or a 2 here, so a 3 has to go here. We got to put 4 and 6 on here due to our gravity rules. Adjacent rule. This is our gravity rule. We have to put our 1 here. Can't put our 3 in either of these. And we can't put our 5 here. We can't put our 1 here. So it's got to go down here. Gravity. This is going to be 2 or 4, but it's going to be resolved by an adjacency rule right here. We can't put our 1 here, so it's got to go here. It can't dominate anything, gravity. Okay, so this is all gravity now. And just as predicted, this would be resolved by something outside. It's an okay puzzle, but I think the thing that would bother you about it is that I had a similar problem with a Simon Tatham puzzle called Mosaic, where it was too simple in a way, too local. None of this stuff is rippling across the board. It's all local. And if it wasn't local, then you couldn't solve the puzzle. This is a kind of interesting area. It's sort of self-contained, but the placement of the numbers is going to affect where we can how to solve them as a unit. We have to solve them as a unit. Yep. And there's only one solution, right? Okay. This is a 2, 3, 4, 5 scenario. Oh, we've got to have a number between 1 and 3. Okay. See, kind of a no-brainer there. And so now we do things like, let's put the 2 here. The 3 has to go here. This can't be a 2 or 3. It has to be a 1. And this would be 2, 3. And that's it. That works, right? 2, 3. Let's try it the other way. 3, 2. This can't be a 3 or 2. It has to be a 1. And this has to be 2, 3. Do both those work? I wasn't very careful when I thought my way through. There. This one doesn't work because it has 2 adjacent 2s. So it's got to be the other one. Yeah. But that's sort of the extent of the ripple effect of the reasoning. Not very far. So I wouldn't give a very high grade to this one. All right. Let's check in on this. generally I think it's good to park and switch threads. It's probably been 10 minutes already. Kuro Kron. Blacken some cells of the grid. Orthogonally connected cells form a group. Each region contains exactly two groups that have the same size and shape. A cell with the number and arrow is always white. It points to a cell belonging to a black group and indicates the size. It's adjacent. Black cells must not be orthogonally adjacent across region borders. Okay. I see. So we're going to have a bunch of twins, a bunch of Kuro clones, black clones. Oop. All right. It definitely points to, and I mean, I guess I should be using black. It's right there in the name of the puzzle. Here, we've got a region of 2, and the only way to do that region is like so. We can't have a larger region, and it can't be across borders, like so. So we're stuck with this region. Maybe I'll make this a little bigger because we're coloring here. Then like so. There's going to be a 1 here. It's not going to be mirrored across the border or here. We can be sure that this one is not one because it would change whichever way we expand this region into a size 3. We're going to have one here. We need to fit 2 3 size regions into this that has, or 3 size blocks. Has region size 8. So there's not a whole lot of room to do that. Like if I put one here, then no matter where I stick the other one, there's not 3 spaces to put another region. So I don't think it can be here. That forces it to look like so. We can't extend the size of this region. There we go. No regions across borders. We need to finish this one. Keep saying regions. Groups. Yeah, can't have touching groups across borders. There we go. This one, I think we're required to have a set of twins in each region. Clones, twins. Okay. If we extend the region this way, then we don't have enough room to make the other one. So we got to go this way. We don't want it to be size bigger than 2. And there you go. Okay. So did find that one fairly fast. Pilot's running. I think it's reading sort of random mail about. Okay. Yep. Hopefully it's just yeah. Again, clearing the table for the next mayor. Let's see. I can tell I'm starting to flag. Maybe there's time for one more. Kuromas or kurodoku. Oh, okay. Yeah. This one, this is in Simon Tatham. This one is range. I think if we look in the instructions, it's gonna tell us that. Kurodoko, kuromas, or where are black cells? Yeah. This is a fun puzzle. I like it a lot. There are things that you learn about it as you go. The weirdest one is sort of like the double counting of vision. It's hard to explain that, but basically, like this one can see 7 cells, including itself. So you can sort of count these 3 vertical ones, 4, 5, 6, 7. So the fact that it can only see up to 5 cells in this way implies that we need to go out this way to see more from here. 3, 4, 5, 6. If I lit up this one, then it would be more than 3. Oh, this one is just 6. This one we're following that rule that we can't isolate any white squares by themselves. This one we know that we can go up to 4 in the horizontal, so we've got to go out 3 more in the vertical. That completes this. 4 this way, 5, 6, 7. Can't go more than 4 this way or this way. There we go. That's kurodoku, kuromas. Kuroshiro, black and white. Um, this is very similar to pearls in Simon Tatham. It's not quite the same. There is turning. So we can see like between 2 successive circles of the same color, the loop must not turn. Between 2 successive circles of different colors, the loop must turn by 90 exactly once. Between black and white, between black and black, it's not going to turn. Between black and white, it is going to turn. Okay, so that's sort of like not going to turn, is going to turn. So we can't run a straight line between black and white. And any turns we've got to do exactly once. Okay. Did I already save it? I did. Okay. We have to visit all of these. We can't go from black to white in a straight line. because there was no turn. So that sort of puts a wall here. And we've got to go like so. We can do a straight line to black, or we can take a turn to white. We can't, again, we can't go through there. Okay. I think this is how we're going to build up our understanding of the puzzle. No choice about the corners, I don't think. About pearls in the corners. So far, I don't think we've really faced a choice about taking straight across the line from one color to a different color. Like all of these ends are going from like the white color to the white color, or the black color to the black color. This is legal. Okay, this is interesting. We can't go this way. This is legal. And we'd have to turn twice to get to this white one. We have to turn once to get to this black, or twice, or all kinds of times to get somewhere else. The loop must not turn. So I think we have our answer here. We can't turn to black, and we can turn at most once. So we got to do this one. We can make this turn because there's a single turn to white. We can go straight to black. We have to go this has to go this way. This can not go straight all the way. It's got to turn early here. Or like this. It says we don't have to visit every cell that doesn't have a circle, I don't think. This one, though, it's in a little corner. And this one's also in a little corner. So regardless of whether we're following the black-white rules, we had to make those moves. Now we can't go straight. Here we go. We can finally apply our rule. We have to visit all of the circles. So this is forced right here. We are allowed to go straight to this white cell or this white cell. We kind of have to enter and exit this little subregion right here. And the entries and exits are here and here. So this one is going to have to exit. We don't know if we're going to exit this way or this way. It sort of looks like we're going to have to turn our way out. Like turn, turn, turn. We could go all the way here, but we would cut off all of this. We can't go all the way forward because we get our one turn and then we'd be at the same color again. We can't go like this because that's too many turns. 1, 2 turns. So we got to go like so. This is a little dead end. Got to go like this. Got to go like so. And we can't go straight to another color, so we do have to turn. There we go. This is a little corner. All right. Not the most compelling content, I know. All right. Cool. Got some cleanup done. Multi-mechanics. Um, Number 3. It is important to have multiple tags when there are multiple mechanics. Cool. And I'm sure if it just said 3, if I just said do 3, then it would have said the same thing, but I just gotta put my thumb on the scales whenever possible. Oh, we didn't quite finish this one yet. Finish. If we turn now, then yeah, we'll have 1 turn to white. That's legal. If we go straight, we'll have 0 turns to black, and that's legal. Same here. 0 turns to black, 1 turn to white. 0 turns to black, 1 turn to white. Ah, we know something about this corner here. We're allowed to kind of go either way. This, we can take this up to this white one, or we can curve it to get to the black cell here or here. And same with this one. It can kind of go in every direction. If this one turns, then it's got to go here. Which cuts off the puzzle in an interesting way. This one would have to go here, here, here at least. And then it could turn like so. But then we're in sort of this no man's land where we've got to get to all of these without having too many sort of turning spots. If we curved this way, then we'd set up a little elbow here. And that would be fine. We would just have to turn this way, and that's legal. We can kind of resolve this either way. That wouldn't work, I think. So turning around this way, kind of weird. We're trying to look at which end to proceed from. And they all kind of work. Okay. Okay. Oh, okay. So it's trying to redo work that was already done in the earlier pass. I wasn't paying attention to that. That's this is all you. Okay, great. Is it done for production entries as well? Um, they were created with a different version of the formula. And then okay, great. I just didn't remember. Okay, sure, that sounds fine. Has QC already been redone? Yes, you should check that. Make sure that the work isn't already done. I don't think it's done though. I don't think we've done QCs on all of these. QCs being a step that makes sure that the staging entries are of quality before they're included in the catalog. Let's see what it says. I don't actually know what it's going to say. Hmm. So from here, we can't say we're going east from here. We have to turn. We can't go straight. We'll run into the same color. And if we make a single turn, we can't go here. We'd have to go here. So either this goes this way or we're going this way. If we do go this way, we can kind of snake around like that. But that leaves a sort of well, it's not too big of a problem. This would have to come down this way. Then it would get stuck. So yeah, I think this actually doesn't work. Coming east from here is not working. Um, let's do a hypothesis color here. Because it has to turn. It goes like this. Um, if we went up like this, then we have to come down like this. We make a closed loop. If we went to the right, that would, um, well, we're already at the point now where we have to we've created a little corner right here. And this has to happen. And now we're actually stuck because we can't take this forward to black and we can't turn to white. Therefore, there's a little wall right here. There we go. That was all forced. This next part I don't think is forced. We are allowed to go this way or this way. We're allowed to go across this way. Now that we've come this way, we're not allowed to turn to white. We have to continue. That created a little elbow right here. Little corner. It's helpful. We can't go north on this one, because if we turned, we'd be turning to white, to same. If we went straight, we'd be going straight to different. Those are the two things we can't do. We have to turn to different or straight to same. So it has to go this way. And now we can't turn to same. Gotta turn to different. We can't turn twice. There we go. We've created another little corner here. And that's the only way through that corner. We can't close the loop right here. We've created a corner here. Notice that our black-white turn to different rule has been observed. Turn to different's been observed again. This would close the loop, so we can't do it yet. Still closing the loop, not allowed. Because we need one big loop. We can go straight to same or turn to different. Either one's fine. If this one goes left, then it doesn't run into the black cell anymore. So it can't turn to different. So it's got a straight to same. And there we go. Let's see, does that look like our solution? Yeah. Cool. That one was better than I thought. I was enjoying drawing out the implications of straight to same, turn to different. Okay, great. So it's gonna hammer on here for a while. I think this is probably a good place to stop it. It's gonna sling hundreds of QC steps out to antiquarians. They're going to try and promote things into the catalog. And then those things will be ready for the inventor to use to check against its new designs and see if it's making something new and interesting. And we might potentially be able to find patterns as well, like mechanics and formalisms that haven't been mined thoroughly yet. Yeah, we're still like working off of the Yanko Encyclopedia and Nikori. I think that's pretty good. We're running a sort of risk that other inventive puzzles have been made outside of these catalogs that we're not taking into account when we make our new design. But on the bright side, I think I think we could at least say that if it's not in these catalogs, it's probably fairly out of the mainstream. Sure. While these work, I'll have the mayor go ahead. And I guess we'll stop it there for the night. So yeah, as always, super great to talk to you all. Super great to have chat. Of course, I encourage it, and super great to sort of chew over these new and interesting machines with you all. So yeah, great to have you, and hopefully tomorrow we'll be continuing to push forward the actual data work of making puzzles using this weird system that we're sort of inventing piece by piece, and hopefully not totally reinventing the wheel on Gas City, but kind of getting off the ground with its sort of modularity and making our own modules that make sense. And hopefully we'll be able to proceed along our refactor as well, trying to modularize our idea of departments and workflows, and also this idea that the team that's working on something should have its artifacts of its understanding of itself separate from the artifacts of its service ownership and knowledge ownership, that kind of thing. Its products, if you want. So we'll try to create that separation between teams and products. Yeah, as always, thanks for watching. Um, I hope the it doesn't get too weird when my lamp turns off. But yeah, come back next time for some more puzzles and computers. Thanks again.